if it's a perfect square and you try to break it down, you're going to be wasting your own time. So that's always the best way to go. So we do have 3 perfect squares here. Hopefully you recognize them. First one, number 1, square root of 64.
8.
Yep. 8. Number 2, this one has a little extra to it. This is 2 times the square root of 16, square root of 16 being, and 2 times 4 is 8. Number 3, 6 times the square root of 196. Anyone know 196 without the calculator?
14.
Yes.
That's crazy, bro.
14.
You got it, bro. Got it.
And then 6 times 14, that's going to give us 84. So there's the idea behind it. Now, what if you don't have a perfect square and just putting it in your calculator and giving a decimal is not going to work for this unit? We need to be able to break it down into a simplified radical square root that's really nice. So a couple of notes. Break down the square root into 2 factors. Then break down each factor as much as you can. Number 4, square root of 32. I hope you recognize that this is not a perfect square. You could always put it into the calculator just to check. So we're going to have to break this down using the factors of 32. Back in Algebra 1, when they taught you, they showed you that you had to identify a perfect square that goes into 32. That is absolutely a way to do it. It is the fastest way, if we're going to be honest. But a lot of students, that doesn't really work for them. So any 2 numbers that multiply to give you 32, besides 1 and 32, are fair game. And it is honestly sometimes quicker to just go with the 2 numbers that come to mind first versus trying to find the highest perfect square. So that's how I'm going to do it. If you prefer to do the perfect square method, go right ahead. So 32. Most people probably think of 8 and 4 when they think of 2 factors of 32. So I'm going to break that down. And you can write those in either order. The goal is to keep breaking these numbers down as much as we can. So the 4 we can break down into 2 and 2. The 2's can't be broken down further without using 1 in itself. So we're going to stop those there. And I'm going to come over here and break down the 8. 8 breaks down into 2 and 4. And the 4 will break down into 2 and 2. That's as far as we can go with those.
Now we got 5 2s.
One more thing before I move on. I got it all the way down to 2. If I try to break 2 down further, I can only use 2 and 1. What kind of number is 2?
A prime number.
Prime number. We're trying to get down to prime numbers. Its only factors are 1 and itself. So, when we break it down fully, you're looking for pairs, 2 of each type of number. So I have a pair of 2's right here. I have another pair of 2's. And then I have a lonesome square root of 2 over here. The rest of these numbers were broken down, so we're not going to use them. So if it helps, I cross them out when I'm done with them. So 4 was broken down, 8 was broken down, and 4 was broken down. So those aren't going to be used. So putting together our answer. When we have a pair of 2's, those are going to make just a nice singular 2, no square root. Same thing with this pair of square root 2's. And we still have to include that square root of 2 that's by itself. Putting this all together, we have 2 times the square root of 2. When you multiply, you can only multiply like things together. So 2 times 2 is 4. Square root of 2 has to stay as it is. We can't turn that into the square root of 8, for instance. There's our answer. A faster way? Intentionally target the highest perfect square that goes into 32, so that'd be 16. If you did 16 and 2, 16 breaks down to 4 and 4.
I got you.
Yeah. That's always going to be the fastest way, but it might take you a minute to come up with it, so pros and cons. Any questions over the process, number 4? Okay. Number 5, we're going to do the same thing there.
So for this, can we just do 28 and 2? Or 24 and 2?
We could. 48 has a lot of factors. I'm taking suggestions. Riley said 24 and 2, so let's go with that. Two is not going to break down further, so it's going to stop there. 24 will break down, and we have options with that as well.
12 and 2.
12 and 2, sure.
6 and 2.
You are taking me the long way, but that's fine.
Am I?
Yes.
I think we
So we can break 24 into 12 and 2. I'm going to cross out 24 because we're done with it. If you don't mind, I'm going to go 4 and 3 on this one. Not that it really makes a difference, but for me it does. 12, you can go 6 and 2 or 4 and 3. I'm going to go 4 and 3. And then finally, that 4 will break down. The 3 will stay. The 4 breaks down to 2 and 2. So we have a pair of 2's here, crossing out the 4. We have another pair of 2's up here. It's okay that they weren't grouped together initially, as long as we have a pairing somewhere. They can be grouped together. So this pair of 2's is going to give me a 2. This pair of 2's is going to give me a 2. And then I have that square root of 3 that's going to be by itself. Let's put it all together. We have 2 times square root of 3. 2 times 2 is going to give me 4, square root of 3. This is our answer. And again, we have a lot of options here. We could have started off with different numbers of 48 and gone through the process. You would still get the same answer. Questions on 5? Yeah.
That number always going to be 2.
Here.
Like, be always going to be 2.
No. Later we're going to have a problem when we have a pair of 3's. It would be a 3. It's whatever number's under the root. Did that answer your question? Yeah. Number 6, 8 square root of 147. Whenever you have a number in front, I always like to set up the answer with that number included so it's not forgotten later. So we're going to have 8 times, and then whatever the square root of 147 comes out to be, that's going to come with it. It's good to start this way so you don't forget it later. Now let's break down 147. I chose this number on purpose because I am very confident that no one in this room could tell me two factors without using the calculator. It's one of those numbers we don't see it very often. So 147, and guaranteed when you're looking for factors, pretty much any number out there is going to have a factor between 2 and 10. So start with the low numbers, go through each number till you find a number you can divide 147 by. Nate, do you have a suggestion?
349.
Yes, we can divide 147 by 3. So 3 and 49. Three doesn't break down. 49 only breaks down one way, and that's 7 and 7. And that's it, yeah. We have a pair here, so we're going to stop with the 7s. And those can't go any further anyway. So these are going to give us a 7. And then we have the square root of 3. So we have 8 times 7 times the square root of 3. Putting that all together, we have 56 square root of 3. And there's our answer. Any questions on 6? Number 7, just throwing in a negative. Negative 2 square root of 54. Again, let's go ahead and set up our answer. It'll be negative 2 times, however the 54 breaks down. $54 has quite a few factors. Most common pair is probably 6 times 9. And they break down quickly. 6, we've got 3 and 2. They're going to stop there. 6 is done for. And 9 breaks down into 3 and 3. We have a pair of 3s here. So that's just going to become a 3. When you have 2 square roots, we're not going to pair these up and then call it a 6. They have to be the same if they're going to pair up and give a whole number. So we're just going to end up multiplying these back together. So we have negative 2 times 3 times the square root of 3 times the square root of 2. Multiply like things together. Negative 2 times 3, that's negative 6. Square root 3 times square root 2 is square root of 6. And there you have it.
You just said it was multiplying back then.
What is it?
You just said it wasn't multiplying back then.
We're multiplying these two back together into a square root 6. We weren't going to turn this into just a 6 without the square root. Like how we did this became a 3 without the square root. We weren't going to do that with these two. It stayed under the square root. All right? If you're ready, go and flip it on over to the back side. This concept is new to everybody in this room. Simplifying with I. I in math, it's actually not a letter. It is a number. Just like how pi. Pi is a Greek letter, but it's actually a number in math. Same idea here. It stands for the square root of negative 1. So these first two problems, these are not going to be negative 2 and negative 7 respectively. If you square root these, it does not quite go the way you think it will. We'll talk about that in a minute. For now, anytime you have a negative inside of the square root, under the square root, you have to take it out and call it I. Let me show you. So we're going to rewrite that negative as an I. And then we'll have the square root of 4, no negative underneath. This becomes I times 2, which is the square root of 4. This last step is a formality. You should know, with your experience working with numbers in X, we always put the number first and then the letter. So we're going to write this as 2I. Make sure you put them in the right order. We'll do that again on number 2. Same thing. Very first thing you'll do is remove that negative and put it on the outside, and we're actually going to call it I. And we know the square root of 49 is actually just 7. And we write our answer as 7I. Number 3, 28, not a perfect square. Let's take a look at that. Whenever you go to start these problems, first thing you'll do is take the negative out and call it I. If you don't, it's a very easy way to forget the I in your answer. So, let's rewrite that as I square root of 28 equals. And then let's go ahead and set up our answer. So I'm going to put that I there, times, and then whatever the square root of 28 becomes, that's going to come after that. And let's break down the square root of 28. I'm sure most of you probably think 7 and 4. Those are good numbers to start with. Seven is nice and easy. It doesn't break down at all, so it's going to stay there. 4 breaks down one more time into 2 and 2. And we get a nice pair of 2's. Putting our answer together, we have I times 2 times the square root of 7. Writing our final answer, we're not actually multiplying anything. We're just putting these things in the correct order. First, we have the whole number 2, then the I, then the square root. 2I square root of 7. Questions on number 3? Do have one quick bullet point to write down here. If you've ever tried this, you already know what's going to happen. If you put a square root of a negative in your calculator, so I'll just do number 1 here, square root of negative 4, you're going to get an error message. That's because these numbers technically don't even exist. These will show up in your calculator as an error. They are called imaginary numbers. So technically, like I said before, they're not real, non-existent numbers, but we do have a name for them.